Alright, so today we're going to go over the debugger for Rust. Actually, it's a debugger that Rust just happens to use called GDB, but that's beside the point. And the reason why I want to go over debugging is because in my professional career, the point at which where I learned how to debug and step through a program was the point at which everything became easier. Because I got to step through my code and to see what was wrong if I really wanted to debug it, which a lot of cases you do. And I got to step through other people's code that I had to interact with, so I was able to figure out if I did something wrong, did they do something wrong, where's the miscommunication? Yeah, all of that stuff. So because of my experience in Python and that, and living half of my life in PDB, which is the Python debugger, I decided to start with GDB. Let's get it. Alright, so let's start off with a definition. I went to Wikipedia. GDB, which is the GNU debugger, is a portable debugger that runs on many Unix-like systems and works for many programming languages, including, and they have this list of programming languages. If you notice, Rust is not on that list, but because there are so many other programming languages on this list, if you really want to find a tutorial on how to use GDB, you can search for practically any language you want that compiles for the most part, but yeah. And then going to the documentation, I'll put all these links in the description, so don't worry about finding them. But yeah, the documentation is here, right? And it is extensive. Looks like I already had that open. But here we go. It is extensive. There are a lot of things here. I read through a good portion of it, but still there's a lot. And here we go. Here's the table of contents, and it just spans. This you can do so much with this. But I digress. One thing that should be noted, close that, is that the Rust support for GDB is not, I don't want to say it's not complete, but there are caveats where there are some things that may be stated in the documentation that you cannot do. And if you ever run into something like that, you should probably check this link because it shows the Rust support and some things that might affect other things. And then outside of that, I did find a cheat sheet, which I'll also share in the description, that is much shorter to read through. But, so going over the thing I said earlier and how I use debuggers, not only to debug my code, but to run through other people's code and figure out what's going on, I thought it would be interesting if I didn't make a contrived example and just did a piece of code that was out in the wild. So, GGEasy, Good Game Easily, is a gaming framework that is built in Rust and inspired by the Love game framework, which is in Lua. I recently discovered it because I was going down a rabbit hole of different Rust tutorials or Rust talks, and I found a lovely person who did at Rusty Fest. I know that wasn't the official name, but she made that joke. So you have a talk there about building games in G-Easy. Sounds like a rapper. So we're going to go through here and we're going to go through the example of Snake and just sort of debug it, figure out what's going on. So let's get that set up. Alright, so in the interim, I cloned the GGEasy repository onto my local machine. I opened it in my terminal and I opened it in my editor. The game that we want to look at is Snake, which is in the examples directory. So open this up, and if we just scroll to the bottom, we see that it's roughly 500 lines of code, so it's not actually that long, and we could read through it, but that's not what we want to do today. We want to try to go through it line by line using the debugger. Just so everybody's familiar with what Snake is, let's play the game real quick. So cargo run, I'm still in target directory, not supposed to be there. Cargo run example 04 snake, and it's you're a snake going around trying to eat things, and when you eat something you become a little bit bigger, and if you want to lose you have to try to eat yourself. There we go. And then the game stops. So that's what this 500 lines of code is. It's this game. All right. So some of the prerequisites in order to debug a binary. One, you have to have a binary, but two, you have to have a binary that is not optimized and has debug information in it. And this kind of just blew my mind when I realized it, because I didn't really think about debugging code, at least via GDB and Rust. But when you do the build or even the run, since it was running in dev, as in we didn't pass in like any flag to make it release build or anything like that, we get both unoptimized and debug information. And the debug information, though I mentioned earlier, it's important because that is the information that the GDB program uses to associate the stuff in the binary with the source code and like the different lines, so you could step through and see what's what. Optimized, the reason why it has to be unoptimized is because if it's optimized, then things might, the naming convention might get changed, where things are located might get changed. It's not going to be the same program. It's in theory going to be the same program you wrote, but it's going to look very different from the way you wrote it. Okay, so once we have those two things, we need the binary, so let's build it. Cargo build example 04 snake. And builds go to your target directory, so cd target. In here we have a debug directory, so let's go there. Oh, I have my headphones on. I didn't even realize I have my headphones on. Let's probably take these off. Headphones are now off. We're going to cd into debug and examples, because we just built an example and we see snake. And to make sure this is the same game, we can just run it. Oh, 04 snake. And it's the same thing. Go through walls and whatnot. Cool. So let's start off with the very basics. Let's start off with opening GDB and having our game associated with it, or our binary associated with it, and closing it. Let's not do any breakpoints for yet. Let's just see what we get. All right. And we can make this a little bit bigger. So you do GDB and the binary 04 snake, and that brings up this screen. We have a lot of information. I honestly didn't read it. It's just a big block of stuff, but you do see the help and some other stuff under it. So we can type help. It gives us things like this. We have a list of commands, yada yada yada, and tells you how to use help down here. Help following class name, help all. Oh, help all commands. That sounds useful. And then we see that GDB has an overwhelming list of options and commands. So much so that the first time I looked at this, I didn't bother to read it. I stopped. This is about the point in time I went to the documentation and just try to read through that. Anyway, quitting. If we want to quit, we can type quit. And I think Q might be short for quit. And that exits GDB. Alright, so let's open it again, GDB. So the way you use GDB is that you set a breakpoint in the program, and then you run the program, which is the program's going to hit your breakpoint and it's going to stop there. And when it is stopped there, you can start interacting with the program. You could go to the next line, you can step into functions, you could continue to something else, you could change variables and what they're equal to. You can do a lot of things. But that's just the general overview. And to even take a step back and go a little bit more high level, or low level, depending on how you view it, GDB is going to run your program in a process. When that process is killed, GDB will still be around. And if you want to rerun your program over and over and over again, you just have to kill that process, like the internal one, and rerun the program via GDB. You can just do it over and over and over again. So for example, let's make a breakpoint. Do a break main. Main being the main function, which we know exists because it's right here. Make that a little bit bigger. Go all the way to the bottom. all the way to the bottom. It's right here. We can see it, right? And break is short for breakpoint. So we can hit run, and it stops there. Now, if we hit run again, it's going to tell us that a program is still running. And it's running in the process that they created for it. But if we wanted to start it from the beginning, we can hit yes, and the program just reran. All right, let's quit out of that. Yes. So one thing I want to point out, because it annoyed me and I ran into this issue, is that breaking at main doesn't seem to work, at least not for me, and I can demonstrate. So I can go into GDB again, right? I can do a break at main, and then I am at main, and I should be able to go to the next line or step into a function. So let's N, which is short for next, do N. Program's not being ran. I need to run the program. That is very true. Run the program. It is now stopped at the breakpoint. Now if I do N, it didn't go into the main function. It started the program and just continued onward. That's not what I wanted to do. So in order to get around that, what I've been doing is, here, let's exit this, quit, yes, come back in. I've been putting a breakpoint at the line after main. So in this case, it is line 490. And in order to put a breakpoint at a line, you need to know the file and the line number. So break, file is 04 snake.rs, and the line number is 490. And we now have a breakpoint there. And if we hit run, we get to this breakpoint, and we have different information now. We have that thread, but we have the breakpoint. We're in main. This is the location, and this is the line, the information there. One thing I learned early on about GDB is the different layouts that you can have. And there's a layout called source, which is the only one I use. Layout SRC. The reason why I use it is because it looks beautiful and it gives me a lot more context into what I'm doing. So here I get to see the line where I'm at, 490, and yeah, everything around it. I can scroll up to look at the rest of the source code. I can scroll down. Beautiful stuff. So earlier I mentioned the command next, right? So next goes to the next line in the same context, or the code block. So N is short for next. I went down to the dot window setup, and I can do it again, which brings me to mode. Eventually I'm getting to build, and build built the window. Put this in front. So another thing I mentioned, or might not have mentioned, S. S is short for step. And what that would do is that would allow you to either step into a function or step to the next line, depending on what your options are. So at this line, we have game state equals game state new, which we're calling the method, I guess, function new to create a new game state. We can step into that to see what it actually does. So we can do S to step into it. And if you notice, the file location changed. We're still in the same file, right? But we're now at line 395, implementing game state, new function, first line. And here we can see what's going on. We can see that we're creating a snake position, creating food position, and then we're initializing a game. Okay, cool. And we can hit next, 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 until we get out of it and get back to where we were. And then after that, we see the program is going to run. So the running is probably where most of the logic is, because it's game loops. And we don't want to step through that, because if we step through that, we can't really play our game. So let's continue. So continue is C, or C is short for continue, I should say, which is short for continue. and that allows you to continue running the code until you reach another breakpoint. Currently, we don't have another breakpoint, so we're just going to demonstrate what it means to run the code, and it's continuing. So right now we can play the game. I can hit up, over, yada yada yada. So let's close out of that. Alright, so we have opened the game in GDB. We have stepped through the main function. We have stepped into some of the things there. But what about when the game is running? What about if we want to see what happens when we hit a keystroke and things change? Okay, we can do that. We can put a breakpoint at the key code portion, which we would have to find. But let's come over here and let's find it. And actually that wasn't too long away. So key down event looks like it's probably it. Key down event gets fired when a key gets pressed. Yeah, that's exactly what we want. So we want to put a breakpoint at that function. How do we go about doing it? Break, which is short for breakpoint, and then the function name, key down event. And we see here, let me make this a little bit bigger, that it says breakpoint 2 at blah blah blah, and it gives you the file and the line. And the line is 473, which is the first line of the function. That makes sense. But it should be noted that it's the second breakpoint, meaning that the first breakpoint still exists. Now, if you have breakpoints and they exist, you probably want to be able to view all of your breakpoints. The way we go about doing that is using info. So info break shows you the list of breakpoints that you have. And let's take a look at this real quick. We have the number. We use the number to act on a specific breakpoint. So if you want to disable or enable a breakpoint or delete a breakpoint, you pass in the keywords disable, enable, delete, and the number of the breakpoint. Type is important because there are actually different types of breakpoints. There is the breakpoint, traditionally the one that we've been using. There are watch points, which allows you to break every time a value that you're watching changes. And I think there are catch points, which I've never used, but seemingly catch errors or stop on errors. The DISP, I have no idea what that does. The ENB is short for enabled, and that is a yes or no. Address, I think that's the address where the point is located. And then here is the line number seemingly. So that one's at 490. So we do not want to stop at the beginning of main. We want to stop at our second breakpoint, which is the beginning of the key down thing. So we have two options. We can either disable the first breakpoint or delete the first breakpoint. So let's do both, just so we can go through the flow of things. So to disable a breakpoint, you type disable, and then the number of the breakpoint. So disable 1. Do info break. We see that the ENB of the first one is now no, so it is not enabled. If you want to enable it again, we can by saying enable 1. Info break, and we see it's enabled. If you want to delete it, we type delete 1, and then it is gone. Cool? Cool. So like I said earlier, in terms of the running of the program, because we need to run the program again, we're still in GDB. GDB still knows the program that we want to run because we gave it as a reference when we called the program GDB. So if we type run again, it starts the program and it's running. And then I hit the up key, and the up key is a key down event. So we've got to our breakpoint. All right, so here we are. Key down event, first line. Let's figure out what's going on. We see that this function takes in arguments. It would be nice to know what these were, and we can look at them. We can do info args, and that is going to show us what was passed in. So we see self, which is a reference to something. Context, another pointer. We see the key code, which is the virtual key code up. I hit the up key. Key mode, don't really know what that's about, but it's here. Repeat, false. Okay? Kind of makes sense. And the line we're at, we see something called dir, probably short for direction, and direction from key code. Ah, I see. They're going to figure out the direction from the key code. That could be interesting. Let's step in, see what it does. Okay, we're taking in the key code. What is key code? So we see that key code comes in as key. So we can try to print the key. We know it exists. So P is short for print, right? So we can print key. And we see that is the virtual key code up, which we saw earlier. That makes sense. And then we're going to match on it. So let's next. It looks like it matched to the first one, and we're good. So in this case, dir, or some dir, should be equal to up. Here we have this long line that's a conditional if statement. We can see whether or not it's true just by going next. And we know that it's false because it went to else. And we have the else statement, hit next, come into the else statement, so we know the else statement was true. And we can see what dir is. Let's print it. Print dir. Understood. And we're changing the snake's direction, which is self.snake.direction. We can probably print that too. Self.snake.dir. So originally the snake was going right. We're changing it to up. Also to note that since snakes is seemingly an object, we can probably print out all of snake. Snake. And there's a big blob here, but it looks like we have all of the fields. You see that snake has a head, has a position, that's the current location of it. It has a direction, which is currently going right. It has a body, which is consisting of a linked list, and they have a head for the linked list, a tail. They have the length, so the size of the snake. If it ate something, last update direction, next direction. Oh, that's kind of interesting. But all in all, you can print out the entire object of the snake and just view it at runtime to see what all the fields are. So this is very good for debugging just in general. So next, let's keep going out of this. Oh, and one thing to note is that in GDB, if you run a command, most commands, not all of them, but next is an example of this. If you hit next, and then the next command you want to run is next again, you can just hit enter. You don't have to put anything in, and it'll just repeat the previous command. So now we're at processing events, and we're processing the events of the key thing. And we're at some weird file. I don't know where we are, but if you look up here, it tells us source platform Linux x11 mod.rs. So Linux specific file for key codes. Sure. Checking if state is pressed, yada yada yada. Looping over something. Alright, so in this scenario, we're looping over something and it's very annoying to keep pressing next. If you're in a function or a method and you don't care for the stuff that is in it, but you want to get immediately out of it, instead of pressing next over and over and over again, which you can do, there is another command called finish, which will bring you to the point right outside of the return. So return from this, and wherever you are there is where you'll stop. And finish, fin is short for finish, so we can use that. And that brings us to the polling event. Cool. Next, I'm not exactly sure where we are. Oh, update. Cool. The game is going to update and then it's going to draw. That makes sense. But let's just continue. Continuing the game, and you can see the person's moving. Okay, so we looked at how movement is done. Now let's look at how eating is done, right? And in order to figure out how eating is done, we probably need to find a point of which in the code where we can break and then just examine it. So let's do that first. I kind of already did it, so I was going through the code, and it's not that long, so you could probably find it quickly as well. But at line 329, here, we see it if condition for if self dot eats food, and if that is true, we come to this line. If we ever get to this line right here, it means that we have ate something. So we should probably put a breakpoint right there, and that is 329. So let's do that. So we can go back to our game, right? Hit a direction because we know we have a breakpoint at a direction, and then let's put a new breakpoint in. Just using this opportunity. Break 04 snake.rs line 329. Cool. We have a breakpoint there. Info break. Let's look at our breakpoints. We no longer want the one at the key down event, which we can see there at 2. The event handler key down event. We no longer want that one. That's 2. Let's disable it. Disable 2, and now we're golden. Continue the game. We can move around now, as you can see, and let's eat something. So I hit right at the right moment so I can eat the food, and now we are here, line 329. So we're here at eat food, and we can see next, and we have this block of code which I found interesting and I think it's worth reading. So let me make this a little bit bigger. If we didn't eat anything this turn, we remove the last segment from our body, which gives the illusion that the snake is moving. In reality, all the segments stay stationary. We just add a segment to the front and remove one from the back. If we eat a piece of food, then we leave the last segment so that we extend our body by 1. So basically what they're stating here is the logic of the game. We have a snake and it's seemingly moving, but not all pieces of it are moving. What they're actually doing is they're placing a new square in the head, which is the direction that you're going in, and they're removing the last square in the linked list, or in the tail. And that gives the perception of movement via the time clock and the event loop ticks. What happens when you eat something is they still put the new place in the head, but they do not remove the end item at the tail, and that gives you a +1. So that's kind of cool. Understanding that, let's continue onward. We have self.update for direction, not all that important. What else is here? Let's make this a little bit bigger. All right, so some food specific things. So ate food. Here we have let new food position, grid position, random. So it looks like here we're about to generate a new location for food to pop up. And to verify that, we can step in, right? And yeah, looking through this code really quickly, we're just generating random numbers between 0 and these max. To see what the maxes are, we can look at the arguments. Ooh. Info args 30, 20. So yeah, that makes sense. Next. Let's just use finish. So we just got out of there, and now we're assigning the food to a new position. So seemingly based on this logic, this game only has one piece of food, and what happens is when we quote unquote eat the food, we don't actually eat it, it just teleports someplace else. That's the basic theory that I'm running on right now. In order to prove it, let's continue onward and see how the game develops. So next. We're at a draw. So let's step into what happens when we draw. We are now at line 450 of snake.rs. We should probably put the game into view. Graphics clear, sure. We're going to draw the snake, which already has been updated. We're going to draw the food, which already has a new position. And now we're going to present that to the screen. So let's make sure we can see everything. And we're going to watch this teleportation happen in real time. Next, enter. So the snake has been redrawn. The head is here. The tail did not get popped off. So we have a +1 in terms of the snake length. And the food teleported to this location. So basically what we just did is we used GDB in order to better understand the source code that was given to us via this example and how it works. And we kind of have a good idea of how it works just from stepping through the code and seeing what each line does. So I think at this point in time, we've covered everything we needed to for the basics of how to use GDB. But there are some other features that I would like to demonstrate. However, this program isn't the best in terms of being able to facilitate that demonstration. So I'm going to go to a different program. All right, so I've opened a different program, and you might recognize it. You probably do recognize it if you've read the Rust book. But this is the Pig Latin program from I don't know which chapter, very early on. Anyway, it is a command line application that's hard-coded in terms of the string that we're passing in, and it just converts that to Pig Latin. If you want to see how that is done, we could just run the program. So cargo run. And that is a string, pig, smile, eat, first, apple, and here's the result. Cool. So let's go through the basics of getting it set up to run in GDB. So we need a binary that has debug information. Cargo build. And then we can go to the target, debug, GDB. What is this called? Pig Latin. Piglet. There you go. With this program, I want to demonstrate watch points and changing variables at runtime. And how that's pretty much just how that's done. So like with anything else, we need to set a breakpoint before we run our program. And I'm going to go with line 62, the one right after main. So break main.rs 62. Now we're going to run, and our program is now running. I'm going to switch to the source layout because that's the one I like. And since we see the source code there, I don't need my editor is big. Cool. So as you can see, we have example, which we can print it, just make sure it's there. We're going to break the example by white space and look at the words. So we can print what the word is. So we see that the first word is pig. Well, maybe we know that we have an issue when we use a different type of word. And pig isn't that word. We want to change it to the word that is problematic. How do we do that? Set word equals, and let's call the word Marcus. Marcus is problematic. And now when we print word, we see that the word is Marcus. And that's going to be, we just changed the value of word. It's going to be like that for the rest of the program. Or at least until it gets initialized or changed again. So we hit next. Oh, one thing to note, when you see things like this, we have multiple lines lit up. You could use Control L to refresh the screen, and then you're back to something that looks nice and pretty. So we're at new string, push, and we have the function Pig Latin, which probably does all of the work. So let's step into Pig Latin. And we're there at the top. We're doing some things. Technically speaking, I think next can take a number after it, so you don't have to keep hitting next. You can just say, I know I'm going to go next 1, 2, 3, 4, 5. Let's go next 5 times, and we're there. You can do the same thing with step as well. So we're here, and I just want to get it into here. So in this context where we have a for loop, we have a variable called letter, and we can print what letter is. It is M, which is the first letter of Marcus. So watch points. Watch is short for watch points, and we say watch letter. And what this does is it's going to break every time letter changes. So we can do watch letter, and we're in a for loop. So instead of hitting next over and over again, we can hit continue, and it stopped again at line 45. And it's noting that the old value was M and the new value is A. And we could do that again. R, C, U, S. Do it again. And we got to the end of the string. We left the block where letter was defined. And because we left that location, it is telling us here that watch point 2, that was just the name, the number of it, was deleted because the program has left the block in which the expression is valid. So it deleted itself when it was no longer valid, which is what we want. So where are we now? We can do next, next, next. Oh, here we are. That again, refresh. So let's step in, right? I'm not even sure what word we're looking at. Let's figure that out. Info, arcs. We're looking at smile. So one thing I forgot to demonstrate, so let's do next 5 times, is when we do a watch point, watch letter. A watch point is just a different type of breakpoint. So we do info break. We see our watch point here. It is number 3 hardware watch point, and all of the commands that you can use for break in terms of disabling and deleting, you can also use for your watch points. They work the same way. With that, I think that is most of the important information in terms of GDB, at least the one I picked up when I was reading it. But I do want to point out something really cool. So there are multiple layouts, and there's a layout for assembly, right? We could just look through all of the assembly instructions line by line. But there's another layout called split, which shows you both at the same time. So you could step through to see what your code is doing, both machine level and in oh, it's not currently executing. Run. Yeah, you can run it over again. So I'm not exactly sure what happened, but let's try this again. Layout, split. Line by line. You can see what happens in your source code, and you can see what happens in the assembly language and the commands that it's running, the registers and whatnot. I don't know assembly, so this is gibberish to me, but it looks cool. Just something to note. And if you want to go back, you can do layout, source. And with that, I think we come to the end of this video. If you like the video, hit like, subscribe, yada, yada, yada. Outside of that, peace.